DevSecOps, integrating security into DevOps. DevSecOps is an approach to software development that integrates security practices into the DevOps pipeline. Instead of treating security as a separate phase at the end of development, DevSecOps ensures that security is a continuous process from the very beginning of development until deployment and beyond. This helps in identifying and fixing vulnerabilities early, reducing risks, and making security an essential part of the software lifecycle. Why is DevSecOps important? Traditional software development follows a waterfall approach, where security is addressed at the end of the process. This often leads to delays, costly fixes, and security vulnerabilities being discovered too late. DevSecOps ensures that security is built into the development process itself, making it proactive rather than reactive. Example: imagine a banking application where security is tested only after development. If a vulnerability is found at the last moment, it might require rewriting large parts of the code, delaying the product launch. DevSecOps prevents this by continuously checking security at every stage. Core concepts of DevSecOps: 1. Shift-left approach. DevSecOps follows a shift-left strategy, meaning security checks are moved earlier in the development cycle. Instead of waiting until testing or deployment, developers run automated security scans and follow best security practices while writing the code itself. Real-life example: companies like Netflix and Facebook embed security tools within their developers' workflows. This ensures that as soon as a developer writes code, it is scanned for vulnerabilities automatically, reducing security issues later. 2. Security as Code, SAC. Just like Infrastructure as Code, IAC, allows infrastructure to be managed through code, Security as Code, SAC, means security policies and controls are automated and written in code. This helps apply security consistently across all environments. Example: a DevSecOps team might write a policy that automatically denies any API request that doesn't have proper authentication. This rule is implemented in code and enforced across all environments automatically. 3. Continuous security testing. In DevSecOps, security testing happens continuously rather than just once. Automated tools scan for vulnerabilities at every stage of the DevOps pipeline. Types of security testing in DevSecOps: static application security testing, scans the code before it is compiled. Dynamic application security testing, DAST, tests the running application for vulnerabilities. Software composition analysis, SCA, checks for vulnerabilities in open source dependencies. Example: companies like Google use SAST tools to scan their code repositories. If a developer writes code that has a potential vulnerability, the tool alerts them immediately. 4. Automated compliance and governance. Security and compliance regulations, such as GDPR, HIPAA, and ISO 27001 must be followed, especially in industries like healthcare and finance. DevSecOps automates compliance checks to ensure security rules are always followed. Example: a healthcare company developing a patient portal must comply with HIPAA regulations. DevSecOps tools automatically verify that data encryption, authentication, and access controls meet compliance requirements before deployment. 5. Secure CI/CD pipeline. In a DevSecOps environment, security is integrated into the continuous integration, continuous deployment CI/CD pipeline. This ensures that every code change is scanned for security vulnerabilities before being deployed. Example: e-commerce companies like Amazon use automated security scanning as part of their CI/CD pipeline. Before a new feature is released, the system ensures it doesn't introduce security risks. DevSecOps tools and technologies. Many tools help automate security in a DevSecOps environment. Some common tools include GitHub Dependabot Sneak, detect security vulnerabilities and dependencies. SonarQube performs static code analysis. OSPZAP Burp Suite conducts penetration testing. HashiCorp Vault manages secrets and credentials securely. Aqua Security Prisma Cloud provides container security solutions. Example: A company using Kubernetes for containerized applications might use Aqua Security to scan container images before deployment, ensuring they are free of vulnerabilities. Challenges in implementing DevSecOps. Despite its benefits, implementing DevSecOps comes with challenges. Cultural shift. Developers and security teams must work together, which requires a mindset change. Tool integration. Existing DevOps tools must integrate seamlessly with security tools. Skill gap. Developers must be trained in security best practices.